Hello, Mr. Salogar here with a lesson on relative time, which is when we put geologic events in sequential order, kind of like the diagram that we have here labeled 1 through 5. One of the things that we need to know right away is that there are some symbols that we will see frequently, and they are defined for us on the Earth Science reference tables. There are symbols for sedimentary rock layers and symbols for metamorphic rocks. However, there are no specific symbols for the igneous rocks. Sometimes you will see a symbol on a diagram and it might be labeled to the side or on the bottom. The first law I want to look at is the law of original horizontality, which states that sediments are generally deposited horizontally by gravity. Therefore, sedimentary rock layers generally form in horizontal layers and they will continue for long distances horizontally. So this is a tube we often use in earth science classrooms to show that sediments settle out in vertical layers. And this is an example from Western New York where we see these horizontal layers continuing for long distances. If the layers are not horizontal, like this example here, we assume that those layers first were deposited horizontally and something happened to cause them to be folded up afterwards. Next comes the law or the principle of superposition, which just says that in an undisturbed sequence of rocks, the oldest rocks are on the bottom. So it's just like making a cake where you put the first layer on the bottom and the last one you put there would have to be on the top. So the order of events here, 1, 2, 3, 4. This is a real world example from Western New York State where we have sedimentary rock layers. We have a shale would be the oldest in this picture, followed by a siltstone, more shale, more siltstone, more shale. That's the law of superposition in action. Next, we have to deal with something called an unconformity. An unconformity is a buried erosional surface between two bodies of rock of different age, and this indicates that deposition was not continuous. So sometimes we will see that there is obvious evidence of erosion. Other times it may not be so obvious. In a diagram, we use a wavy line to indicate that there was erosion across here. In this case, we could identify that there was an unconformity because we have fossils from two different time periods, one being the Cambrian from 542 to 488 million years ago, and then jumping up to the Devonian time period, which was 416 to 359 million years ago. And we can see that a really big chunk of geologic time is missing in between, and that is called the Ordovician time period. Here's another example of an unconformity. We have some folded layers and some horizontal layers. So in between the folded and the horizontal, there had to be a period of erosion to cut this kind of flat before these new horizontal layers could be deposited on top. Here's another example of some folded layers. This wavy line across here would be our unconformity. So the order of events would go sandstone, shale, limestone, siltstone, conglomerate. All this gets uplifted, folded, and then there's a period of erosion followed by deposition of these new sedimentary rock layers on top. Next, we have the law of cross-cutting relationships, which states that a fault or a body of rock that cuts through another body of rock must be younger than the body of rock it cut through. So here it is in action. We have a diagram with some horizontal layers which have been broken by this fault. Some of the layers have shifted down, some of them appear to have shifted up. We know that it wouldn't form this way, so we know that the fault has to be younger than all the layers that it cuts across here. Sometimes we'll be dealing with igneous rock intrusions like this one. We have an igneous rock layer that is cutting through sedimentary rock layers. So the order of events here would be sandstone, followed by shale, then an unconformity. We've got limestone, and then an igneous intrusion. The contact metamorphism tells us that those rock layers were heated. They could only be heated if they already existed there first. Here's another example where we have some shale, followed by limestone, and we have more sandstone. We can see that there's an intrusion and a fault. We know that the intrusion would have had to have come first, followed by the fault, because the fault splits the intrusion. Then we have the erosional unconformity across there, followed by the siltstone on top.